Okay, the last thing you have to do today is graphing quadratic inequalities. So this is two variable. So it has a y and an x. But we graph it just like normal, except for at the end, we're going to say graph. If it is a greater than, a less than, or greater than sign, it is a dotted parabola. And if it has that line underneath it, it is a solid parabola. And then you have to figure out where you're going to shade. And so your solution is the graph itself. All of these are in standard form. So we're going to do the axis of symmetry, the vertex, and then hopefully just find the slope. And that'll be enough to get our 5 points. So axis of symmetry, A is -1, B is -4, C is -8. So x equals -b over 2a. So that's -2. So x equals -2. So here's my line of symmetry. My vertex is always on that line. So I'm going to plug in -2. Whatever I get out is my y. So ignore the inequality sign as you're graphing it. So that's -4 plus 8 minus 8. So those will cancel out. I get -4. So -2, -4. It's opening down with a slope. A is 1, so -1, -3, -5. So down 1, right 1, reflect that. Down 3, right 1, reflect that. This is equal to, less than or equal to, so we're going to do a solid line. And then with shading, when you plug in a point, as long as it's not on your graph, I use 0, 0. Or you can go inside your parabola. So you could do like -2, -6, but you're using a point now. So, and you're either going to shade inside the parabola or outside the parabola, basically. 0, 0 is the easiest as long as it's not on your graph. That's what I would use. 0 is less than or equal to -8. Is 0 less than -8? No. Shade away from there. That's where people get confused. So I tested this point. It was not a solution, so I shaded where that point isn't. That point isn't in the parabola. It's out of the parabola. Another way, less than is below your parabola. Less than below my parabola. Greater than above your parabola. All right, let's do it the other way. A is -2, B is -8, C is -12. So x equals -b over 2a, -4, so -2. So it's over here. Remember, these are the nice form. Standard form is your y-intercept, because if I plug in 0, I get out -12. If I plug in 0, I get out -8. So those are nice just to check it if you got it right. So here's your axis of symmetry. Your vertex, I'm plugging in -2. See what we get out. -4, -8, 16 minus 12, -20 plus 16 is -4. -2, -4. Right here. 1a, 3a, 5a. A is now -2. So -2, -6, -5. So down 2, right 1. Down 5. 1. Up, sorry, down 6. 1, 2, 4, 5, 6, right 1. So this would be -10 if I plug in a 2a. We're not plugging that point though. Reflect those points. Look, this point was already graphed because it's my y-intercepts, but it makes me confident I know I graphed it right. All right, I'm going to get rid of my line of symmetry so it doesn't confuse you. It's just to help you graph. Not actually supposed to be there. Now, this sign, this is all the new part. All these dots are normal. Everything that we just took a quiz on yesterday. So this sign is less than. So we're going to have a dotted line. Any points on this are not solutions. Some teachers go as far to make you write open circles here because those would not work. It would not make a true statement. If I plugged in negative 12, 0, negative 12, it would say negative 12 is less than negative 12. That's not true. So that should be an open circle. But as long as you put the dotted line on that, I know that you know that these are dotted lines. These are open circles. It is not including, the dotted line means it is not including the points on the parabola. All right. Less than, we shade below the graph. Below the graph is inside the parabola. If you do not like that method, you can always test a point. Again, you're testing a point, an x and a y. So if I test 0, 0, 0 is less than negative 12. Is 0 less than negative 12? No. So we're not shading where that point is. Okay. All right, I'm going to graph the next one. I'm going to pause the video. You know how to do all this. So you pause the video, you graph the next one as well, and then play it, and we'll start back at the same point of dotted line, not dotted line. Okay, so I went ahead and got all the points, found the axis of symmetry to be 3, found the vertex to be 3, negative 1. After I plugged 3 into the equation, my slope was 1a, 3a, 5a, a is 2, so up 2, right 1, up 6, right 1. To check, my y-intercept would be all the way up at 17, which is where that looks like it's going. If I go up, oh man, I did that wrong again. If I go up 10 and right 1, 7 plus 10 is 17, so that is correct. So the new part, this is all on our quiz. So the new part, it's less than, so it's dotted lines. So any points on this parabola are not a solution to the equation. Less than is below, but now that my graph is opening up, below is outside my parabola. So all of the points outside my parabola are a solution. Again, you can test a point. I always test the origin as long as it's not on my parabola. So 0 is less than 0, 0, 17. Is 0 less than 17? Yes, it is. That point's out here, so I need to shade out here. If I have tested inside my parabola, choose a blatantly obvious point, like this point, 3, 4. It's going to be harder because now I actually have to plug in points. I have to do more math than just zeros. So y is 4 is less than 2 times 3 squared minus 12 times 3 plus 17. Back to the original graph, x is 3, y is 4. So 4 is less than 9, 18 minus 36 plus 17. Hey, I already did this. This was the vertex when I plugged in 3. So negative 1. So is 4 less than negative 1? No, it is not. So we do not want to shade where that is. Okay, again, pause the video. I'm going to graph my 5 points and then I'll start it again. Okay, careful with this graph. If you notice, it is counting by 0.5s. So when you're going up 1, right 1, make sure you are counting a whole 1. Up 3, right 1, up 5, right 1, a whole 1. If you wanted to check, your y-intercept is at 0, 3, so that's good. Again, this is a dotted line because it's less than. If it was greater than, it would be, or it'd also be dotted, but that equals 2 makes it a solid line. Less than is below your graph, or you can check a point, 0, 0. That'd be 0 is less than 3. That's true, so I shaded where 0 is. Or if you wanted to check the middle, negative 2, 3 looks like a good point up here. Definitely in my parabola. So 3 is less than negative 2 squared plus 4 times negative 2 plus 3. So 3 is less than 4 minus 8 plus 3. 3 is less than negative 1. Is 3 less than negative 1? No. So we are not shading inside my parabola. All of these points are not my answers. All of the points outside of my parabola are my answers. Okay. If you go to Delta Math, I'm not really a fan of how it's set up, but it's graphed for you. The parabola is graphed for you. We just have to figure out the equation. So they're all very same. I wish they had written them in standard form, but they're very easy just to get into standard form. Minus the 5 over on all of them. So a lot of you can do that in your head. There we go. Now, they're all minus 5, so my y-intercepts are all negative 5. This is a solid line, so they all have the lines underneath it. Now we're just trying to figure out how are we shading. Are we shading? Oh, we have positives 4s and negative 4s. So let's check that. We can do factor it and find our x-intercepts. So that'd be 5 and 1. So x plus 5, x minus 1. Okay, with a plus 4, I get an x-intercept of negative 5 and 1. So it can't have the plus 4 in it. So it can't be these. So if I had the minus 4x, then my signs are changing, right? So that'd be positive 5 and negative 1. Positive 5 and negative 1 is what I want. Okay, so it has to have the negative 4 in it. And then we're shading above my graph, above it, so greater than. Or you can test a point. 0, 0 is inside my graph, so if I test 0, 0, I always test it to the original, so let me clear something out. Or all of it out. Okay, sure. So if I'm testing 0, 0 in this one, we get 5 is greater than or equal to 0. Is 5 greater than or equal to 0? Yes. So where 0, 0 is, we would want to shade. So that is how you eliminate all of them. I can do one more with you. And then I gotta go. I got to go. Okay. All right, so we're gonna imagine all the negative 14s over here. Not think about them over here. So it's x-intercepts are, where are they? Because look, we have a negative 9x and a positive 9x. So I'm gonna factor. Try to get a positive anytime you can. Keep a positive. So I'm gonna divide everything by negative 1. And then we'll have x squared plus 9x plus 14. 14 is 2 and 7. To add to 9. So x would equal negative 2 and x would equal negative 7. Well, that's wrong. So it must be the other one. Divide by negative still. So all my signs change. So that'd be x minus 2, x minus 7. So x equals positive 2, x equals positive 7. This is what we want. We want the positive 9, not the negatives. So that goes away. The graph is shaded above. Above is greater than. Or you can test a point. If I test 0, 0, 0, 0 is outside of my parabola. So if I test 0, 0, y plus 14 is greater than. I'm going to test the one I think it is, the bottom one. Negative x squared plus 9x. I'm testing 0, 0. So 0 for x, 0 for y. 14 is greater than or equal to 0, 0, 0. 14 is greater than 0. Yes. So we shade where that point is. So I am right in 7. Greater than, above, less than, below. Or test a point. Your choice. Okay? Guys, I assigned 3 of each. I do not want you to have homework this long weekend. Get this done. It's due before you leave class so that you don't drag your feet. Have a great day. Have a great long weekend. Stay safe.